And I am live. That is pretty cool. Shit. Yep. And today is 21st of September 2025, Sunday, and we are back on CP31 sheet. Yes, we will be solving CP31 questions. And yesterday was a contest. Today is a contest, and yesterday's contest was pretty amazing. Why? Let me show you. Yes, the camera is fine. I got a positive delta, and I am almost at specialist peak maximum 1386 and current is also 1386. That is peak performance. Hello, shit. Bro was just waiting there. Yes. How was your contest yesterday? Uh, Mine was bad. Shit. Did you get stuck on the second question on B? Solved only two. First one was okay. Second one was difficult. For me, it took me a lot of time. Question number B, because that not number, question number, question alphabet B. B was kind of new, but yeah, I got it. And then C, for C, I used dynamic programming. And while I was solving C, I saw that Dominator 69 submitted C twice, but both of those submissions were wrong. And I thought, shit, okay, we are getting there. Yeah, yesterday was good. I mean, but yeah, it was, but figured out mine wasn't able to solve C. Yeah, C. I don't know how I was able to solve C. I think it was because of the dynamic programming thing I have been doing, and it helped me. But yeah, you will get better. Just keep solving new questions, and that will be cool. And yes, so today we will continue with CP31, and that is cool. And there are like new features in here. Continue solving. I don't know what focus mode does. It just changes this thing somehow. And now this one, factorials and powers of 2. This is the one that we are going to solve. Yep, it is updated. Yeah, things are different in here. Position 1, 2, and 3. I don't know why they share different places, even though they have solved the same number of questions. Yeah, I mean, yeah, shit. Cannot put everyone on position 1. So we have a leaderboard, this calendar, this thing, and bookmarked notes and stuff like that. That is cool. And yes, and also I would like to show you this thing. I added a few extensions and we have this thing. I have solved 57 problems at 800 level, and so this extension shows these bar graphs, which is crazy, and all of these like the tags which I have solved. I solved 146 greedy algorithm problems, which is like the most amount of things, and maths 137 problems, and 137 is a nice number. And yeah, 2 sat 1 problem, so this is pretty nice. Wait, let me put obvious there. Yes, today's contest. First one solved first. Huh? Yesterday I was frustrated, so today I have started CP handbook, and that is cool. That is cool. Just do not give up. Just continue going forward. Yes, today is going to be fine. Can you tell me the good DP resource? DP, I have done DP from CLRS and like CSES questions and CP handbook competitive programming handbook, and a couple of YouTube videos, like random YouTube videos on dynamic programming. Dynamic programming, Erecto, problems, lead code, dynamic dew points. Okay, that is a suggestion, not something I searched. Dynamic programming, dynamic programming, dynamic programming, dynamic programming. This one, dynamic. Wait, shit, I didn't watch this one. Yeah, yeah. And there is algorithms live video. There is this MIT course video which you can watch. There is this video, and yeah, so random videos on YouTube you can watch for dynamic programming, and just this book. This is the main thing for my DP thing. And let's continue with this CP31. Okay, it is going to be fun. See, stopwatch. Shit. And tmux skill server, tmux set, tmux attach, tcp, cd1500, start vim. Okay, we are here and now we can begin. Sometimes it works, yeah. Okay, I have seen few, but it is very hard to make it for all problems. Sometimes it works and it doesn't. Yes, all the dynamic programming thing I've done it in two phases. In the first phase, I watched Eric To's video and did a few coin change problems, and I left it there. And then I came back to dynamic programming and did all of this, which I have been doing for the last week or so, from the CLRS book and going deep comprehensively. And now again, I have left dynamic programming. I have only done these problems. There is 1, 2, 3, 4, 5, 6 questions left, and these questions require, I think, more knowledge than just simple dynamic programming, because I read editorial for, I think, this one, elevator rides, and the editorial said that I need to know about bitmask dynamic programming. So I don't know what that is. So all of these questions which are remaining, they need a bit more understanding other than dynamic programming, and I can do them slowly on my own without off stream. And yes, let's get to this thing. A number is called powerful if it is a power of 2 or a factorial. I think I, yeah, tried this problem, but I was unable to do this last time. A number is called powerful if it is a power of 2 or a factorial. In other words, the number m is powerful if there exists a non-negative integer d such that m is a power of 2, or this thing, or a factorial of some number. In particular, this, okay, we are treating 0 factorial as 1. For example, 1, 2, 1, 4, and 6. 6 is 3 factorial are powerful numbers because these are not. You're, you are given a positive number and find the minimum number k such that n can be represented as the sum of k distinct powerful numbers, and say that there is no such k, minimum number k. So that is just coin change, literally coin change, where I cannot use coins repeatedly. That should be easy. And I remember that I did this on a stream, but I don't know why this is not completed. Maybe I messed up the last time. Shit, this is the code that I wrote. Fill packed. Let's write from scratch. Okay, and these numbers, The number of coins. N can be 10 power 12 at maximum. Okay, so I cannot run a loop 10 power 12. That makes sense. Do I use a greedy algorithm for this? No. I'm thinking of when is this not possible? This should always be possible. 10 power 9 is 32 bits. So 32 numbers. And then 10 power 12 that can be represented with less than 64 numbers, of course. So for this, the number of coins, so-called coins, is not a lot. And the same would go for factorial. There is not a lot. Okay. So what is the catch? There are four numbers. First one is 7, which is 6 plus 1, 2. Yes, 6 plus 1. Then 11 can be 3 coins. For 11, in coin change, we run a loop from 0 to n, and we to fix that. Okay, this is the only problem in this question is the same one. Hello, bro. Yes, that is something that can happen. You can just, yeah, you will have to work it out. CP sheet, I want to be able to solve many of the bit problems without hint or editorial. Wasn't you know, the C problem was a little similar to one of the ICPC final problems, like statement wise. Shit, I have not read ICPC problems. Shit, I'm not into, and yeah, I have not done that ICPC problems, but I will look them up. That is fine. And yes, so in this problem, the main problem, this is easy. If we use the basic coin chains, this is easy. But I've seen this pattern, I guess at this point, 3 times. Here, generally, when we are solving DP problem for some number n, we go making sub problems from 0 till n, right? But and n generally is around 10 power 6 or 7 or 8 something, and that is fine. But now 10 n, shit, wait, that n is pretty crazy actually. But now n is 10 power 12, and we cannot have a loop going from 0 till 10 power 12. And this is the problem in this problem, and this was the problem in CSES DP problem, I guess this one. Yeah, here x was pretty big, 10 power 9, and also in at coders DP question knapsack 2. So okay, shit, okay, so we do not have to go through every sub problem. I think what we can do is recursion here, because in recursion we will be skipping a lot of sub problems which we do not need to solve. Yes, and I think recursion would be better, and we can have a map long to long. I think that recursion is the answer to this one. Let's see. First of all, we will have a vector of the arrays, and vector for which has all the coins or the numbers which we can use. Hello, hey bro, I'm in 10th standard. I have learned coding till decent extent in 7th and 8th. I am preparing for JEE. What technology should I learn and how do I manage it? Okay, if you, okay, you do not actually have to go to college. You are in 10th standard right now, so you have half of this year and then 2 more years, 11th and 12th. And in 2.5 years, if you study pretty like mildly even, you will get really good at programming and you will realize that you don't actually have to go to college and you can manage on your own. And going to college is not really worth it because it is just going to waste your time. But you can go there if you want to have the experience and all that, going out with your friends and things. You can go to college, join college for that, but do not depend on college for studying because they will not teach you anything which is going to be useful. The only benefit of college is the social thing, that you get to meet new amazing people who are better than you and you can learn from them. That is the only benefit for college. And if you already have people who are smarter than you, who are your friends, you don't actually have to go to college then. But you can go for the experience. And for the JE thing, I would say focus on learning on programming. And for JE, I mean, I just got a 84 percentile, so I don't think I'll be a good person to ask this. Hello, should we already have AI here? That is crazy. Okay, let's build the vector. Let's call it points and a function, or let's call them nums, and a void function, fill nums, and it doesn't take anything. And yeah, long I equals 1, and I will have a set of long s, and while I multiplied by I plus 1, yeah, s dot insert I multiplied by I plus 1. And also let me say what the range is. Cons long range equals 1 e 12. That is the exact range. Yes, let's say 1 e 12 plus 1 6. While if I get the next factorial, if that thing is still lower than range, I can do I equals I multiplied by equals I plus 1. Set. No. N for int I equals 0 or I equals 1, I less than, or I into n is less than range deranged I plus plus s dot insert I into n and n into multiplied by I. So I will add 1, then I will become 2, and I will see if 1 into 2 into 1 is still smaller than range. I will add 2 and so on. So all the powerful numbers because of the factorials will be there. And yes, and now again for int I equals 0, I less than or 1 long left shift by I. If this thing is smaller than range I plus plus, add this f dot insert 1 long left shifted by I amount. 0, 1, yes. And then we can say nums. Can I do this nums dot assign s dot begin and s dot end? Is this okay? LSP start blank d. Okay, it is okay. It is okay. It is okay. So that is cool. And here fill nums LSP stop. And you, yes, you have been very consistent for a long time. YouTube suggested me your videos. I wish you all the best. Thank you. Thank you very much. Keep working hard and you will achieve great things. Okay, yes, thank you for that. I will achieve great things. Thank you. Thank you a lot. Okay, now the coins are filled and I think I should pre-compute the answer to all the n's. Should I pre-compute? What is the maximum number of test cases? 100. 100 times. What if I get the same n? Bottom up DP. I think I should write another function and it will fill a map long which is going to be the target and int which is going to be the number of numbers, the count of numbers which we use to get to some place, and fill map void and mp 1 equals 1. I need 1 point to get to the sum, to get to the value 1. And okay, we can write a push forward DP approach. I think we can write a push forward DP approach in this, where I already have all the sums which I can reach, and on each of those sums I currently have the best value, best amount, number of coins to get to that sum. And then from all the coins that I have, I will see how many I will see for each coin what is the new value that I could reach using this current coin. But the thing is, I cannot repeat the coins. All have to be distinct coins. That is crazy. So there is only a subset of coins that I can get to. Okay, and what is actually the size of this? C out s dot size 52. There are 52 numbers in the set. 2 power 52. There are going to be in total 2 power 52 total combinations, which is a lot of combinations. Yes, I cannot have answer for every number in there, and these 52 numbers are distinct, so there is no point in, I think, pre-computing the value. Yes, okay, there is no point in pre-computing on the value. Then to define a state, I would have to use multiple things. First of all, uh, the number that is to be achieved, and second, the number of coins which have been used, of numbers used to get there, and also which numbers were used. Which numbers were used. But how would I represent this thing? Because representing this thing just needs a singular number. Representing this thing also needs a singular number. But representing which numbers from all the possible numbers which could be used were used, representing that a set is good, but I do not want to be passing a set down, right? Because for each function call, if I do write a recursive function, then at each number I have 52 choices, and I would have to send, if I'm sending a set of all possible coins which could be used, I would have to send 52 different sets with 51 elements to all of these subsequent function calls. And wait, I that is actually doable. Shit, that is actually doable. If I just send a singular set to each function call, yes, I can use a single set. Yes, I can use a single set to do that. Why? Because I can use a reference to a set, and first I will remove the number which I'm using, and I will call the function with that set with one number removed which I am using, and then I will add that number back to the set, and then remove another number which I'm using and call the function with that um, smaller subset, and that is cool. Okay, integer, this will return a integer, and recursive, that is a very original name for the function, and this is going to take a long number n, that is the target number, and a set of long. Why are we using a set? Because it is easy to remove and add elements to a set. Yes, I think that is kind of enough. And if the number is directly in the set, if s dot count n, if n is in the set, then return 1. Else, if that it is not in the set, then we will have to go through the set. But there is one problem, and hmm, and that wait, shit, I remember something. Yes, I am exploring DSA myself, following is drivers series. That is nice. Done with almost all the concepts. I'm practicing DP and graph related problems. DP is nice, graph is also nice, geometry is pretty cool. If the task is just to add and remove and not to maintain order, unordered set is a better option. Yes, unordered should actually, in this case, unordered set is fine because we only have 52 elements. Unordered set is not good when we have a lot of elements, but here unordered set is fine because we only have 52 elements. But since we only have 52 elements, unordered or ordered both have almost the same time complexity, because internally it uses red black tree, and but the thing with unordered set is that the overhead in insertion and deletion is very big, and that is not pretty cool because every key, when you search it, it goes through a hash function, and that hash function takes a lot of time, even though it is constant, but the time it takes is quite big. So that is not always very good. And also in this case, we only have 52 elements in the set, 52 elements. So log 2 would be around just 6, 5 point something, and that is fine. That is not very big. So this is fine. But instead, I remembered that in CPHP, there was a complete search thing pruning, generating permutations. There was a method of generating permutations, not this one. Yeah, I think this is the one. I think we can use this thing. Process the permutation. Uh-huh. And this is going through all the permutations. Hmm. This is essentially the same thing that we are doing here. And going through all the permutations, there are going to be 2 power 52 permutations. Chosen I continue. Hmm. Shit, this is just this is the same thing that we are doing here. Here, this is just a recursion, and here is the iterative form for the same thing. The time complexity, I believe, is going to be same in both the cases. And I think it is going to be very big than what we can handle, which is a bad thing. Therefore, we do need some amount of pre-computation. I think this is fine. This is fine. This is fine. This is fine. Without now, I'm deciding between pre-computing something and not pre-computing something. And I think pre-computing is could be very bad because pre-computing would look like here we pre-compute answer for every possible n that is out there, and in total there are going to be 2 power 52 possible values for n, and we do not want something this big in the memory, right? Because this is very big. 2 power 32 is 10 power 9, around the same. 4 10 power 9, and this thing is just really big, bigger than this, a lot bigger than this, and a array of size this 10 power 9 is already too big. This is like 1 GB or 4 GBs because every element inside is 4 bytes. So this is like 4 billion bytes, which is 4 GBs. So we do not want to pre-compute given that reason. And if we do not want to pre-compute, then we write our recursive call. Yes. So we need a separate set, long ss, which takes in s. I think this is doable. lsp start lang d. Yes, this is cool. Okay. lsp stop. And now we can iterate for long reference x in s. If x is smaller than or equal to, it is not going to be equal to because we did see it. So if x is smaller than n, then remove this element ss dot erase x and recursive what, and also we will say long int best is n max And since we are using int max, we will have to include c limits, c limit or limits, something like that. And here we can remove this part. And recursive function, we will call this function, and wait, best equals maximum between best or recursive, call the recursive function with n minus x comma ss, ss as in like Staffel, and then ss dot insert, that is very Nazi, ss dot insert x back, return best. I am worried about just the time complexity and not the correctness for this algorithm. Yeah, really long n, c in n, and c out recursive n and nums. Okay, c limit was the wrong thing. Okay, c limits then. C limits is okay, it is correct. Now long reference in S is wrong. Why? Long S int recursive long integer S nums. Wait, nums is not long. It is long. It is a vector. My bad. Shit. Uh, set add things in nums and replace this SS with nums. We are filling nums. Okay, SS line 30 binding reference of type long int reference to const long. Who is saying it is const? Okay, it is like it is taking time, right? Shit. TLE s dot for long x or auto x equals s dot r begin while x is not equal to s dot r end and x plus plus. And here also go to x, go to x. I thought hopefully this might be faster, but my bad. No. Hello. My assumption was that input size can vary for different test cases and amortized time of unordered set will beat the time complexity of set. Hmm. It would if it were something like a array. In array amortized analysis, amortized time would beat the time for, like, compared to a set. In a set, if you have n elements, inserting each element takes log n time, where n is the number of elements that are currently in the set. And let's say you are adding n elements in total, so it is going to take about n log n total time to insert everything in the set. And asymptotically speaking, unordered set is, I think it is going to take n time. Yes, I think it is going to take n time. But and also a vector, if you use a vector, it is also going to take log of n time. So this is for unordered map, and this is for a vector. But this thing is bad, and this thing is good, and this thing is like okay. Okay. Why? Because generally, not generally, here in both of these things, in a vector and an unordered set, set or map does not matter, same thing. You have, in unordered one, you have a space, a memory location in which you are storing things. And whenever you get a key, a hash function runs on this key, and you get some modulus and you get some index I, and I is going to be the index in which you store the value associated with your key. And you just keep doing this v1 v2 when you have a bunch of values, and at some point there is going to be not enough space to put new values, and for a hash collision you would create a linked list or something to store two values at the same index. But at some point you will see that this thing is very small and you cannot store more keys. Then you will create another vector in the memory, and then when you are doing this, first of all of these elements will have to be shifted into this new vector, and that new element will also be shifted onto this new vector. But to shift all of these elements, the difference between a normal vector and an unordered something, unordered map or set, is that in a vector, when you need to see where any particular element is going to go, it is just the index in which it is currently stored. So if this v1 value was initially stored at index 0, it is going to be stored in index 0 in the new vector. And if this v2 value was stored in at index 1, it is going to be stored at index 1 in this new vector. But with a unordered map or set, this value, the key for this value k1, has to go through a new hash function, and whatever the new index is, I dash, for this key, that is the place where this value will go in the new vector. So just finding out where all of these keys will go into the new vector, it is constant, time, but this constant time is very big because every key has to go through this hash function to calculate or find their new index in the new vector. And that is very time consuming, because if you have a lot of keys, n keys, each key will have to go through this bulky hash function, which is not very good. So what you can do instead is, this is the problem, right? You had a smaller space in which you are storing these key value pairs, and you had to update, and in updating them you had to run all of these already present keys through the hash function again to find their new vectors. So increasing the size of the vector of the space in which you were storing the key and value pairs was the problem. So what you can do is, so that is too small. What you can do is unordered set, create some unordered set of, let's say, integers st and an ordered unordered set. I think that is the correct way. And then you can do set st dot reserve 1e6, let's say. And what this means is this space, this initial space which you create in which you are going to store those key value pairs, its size is going to be 1e6. So this condition, when you have to increase the size and create a new uh, location in memory where you are going to shift all the previous keys, is very unlikely because you already have a space in memory which is big enough to hold key value pairs according to your need, whatever your need is. And therefore this creating a new vector and creating a new space and shifting all the previous keys is now gone. And this thing, if you do this reserve thing, this is going to beat normal set. This is going to beat normal set because in normal set the time complexity is log n, right, for 10 power 6. But in this reserved set, you just run your hash function on every key once because you are not shifting it. So you are not running your hash function multiple times on a singular key to find its new and new index. So here the time complexity is n and the constant factor here is smaller than this log n factor, and therefore here unordered set is faster because of the reserve statement, and that is cool. Hello. New to CP and competitive programming. Should I watch this? I mean, it is up to you. Yes, and yes, I am aware of hash function collisions and avoidance techniques like open addressing and chaining. Yes, open addressing and chaining. But since you have distinct elements and only 52, the collision is very unlikely. Yep, here the thing would not matter. The time complexity is just log n for unordered set and n log n for ordered set. And I just find this thing very fascinating that you can just do this, do reserve space for the unordered set beforehand if you already know the number of keys that you are going to put in, and the bad things that come with this high constant factors go away, and that is pretty cool. And let's read the editorial for this one, which is fine. I do not have to feel bad about it. C, the time complexity, or okay, at least for my sanity check, let me test, is this like working at all? G++, the name is C factorial / out, and okay, we can leave the last one. Shit, okay, it is taking time. Three values, 7, 11, and 240. Okay, it is taking time even though it shouldn't. Okay, shit, there is also another condition. If n is smaller than 0, if n is smaller than 0, if it is negative, then return -1. Then return minus 1. Then no. Let's use int max to say that there is no answer. And in here, if, okay, long answer is recursive n with nums, call this function. And if answer is smaller than int max, then see out just answer out answer is smaller than int max question mark. If it is smaller than int max, then output answer. Otherwise, output, wait, what do I output if there is no such value for k? Otherwise, print a single positive integer, the minimum possible value of k, or otherwise print minus 1. Minus 1. Mhm. Okay, shit, I got bad answer for them. Slash out 3, 7, 11 to 40. Yep, that is taking more time than what is necessary. Why? Go to x less than n. Minus 1, minus 1, minus 1, which is wrong, which is like absolutely wrong. S dot count. So why is this thing not working? Because for 7, I'm saying I cannot reach a sum of 7. I should be able to reach a sum of 7. Ludicrous behavior. Okay, let's read the editorial. C. Solution. Yes. Yo. LinkedIn. Shit, bro is passing in Morse code. Reserve is great. Yeah. For 52, we are talking about some microsecond performance improvement. Yeah, and that is fine. Hello, he's back. Depends, but it will always be good to use things which work efficient in most cases. Yo. Hello. Assalamu alaikum. Ball stories. Walaikum assalam. Yo. Cool. Factorials. Okay. I do not have to feel bad about reading the factorial editorial for the factorial. If the problem asked to represent n as a sum of distinct powers of 2 only without factorials, then there is a unique way to do it. Yes, there is a unique way to do it. Find the 1 bits and fix them using the binary. Okay, so I think, shit, okay. Oh, okay, I do not want to look at the editorial. I can create, if I have n in some binary representation 0, 1, 1, 0, 1, 1, 0, and I have a factorial number. Let's say we have 7. 7 in binary is 1, 1, 1. And the first factorial numbers are 1 is 1 factorial, 1 is represented as 1, and 2 is 2 factorial is 2, which is 1, 0, and then 3 factorial is 6, which is 1, 1, 0, and then 4 factorial is 6, 12, 2, 3, 6 is 6 to 24, and 24 in binary would be 0 here, 8, 16 plus 8, 16, 8, 4, 2, 0. Yes, this would be 24. And what I need to see is addition. I could use factorials, right? Uh, Shit, I thought if I use one of the factorials and whatever remaining bits I need to get up to this sum, I can fill them up using powers of 2. But I could use 2 of the factorial values, and that would also help me, right? If here 2 factorial is 2 and 4 factorial is 6, and if I add these two I get 8, and if I had to get to 8 I could use a singular power of 2. Okay, and if I have this 24 and this in 20, if I have 3 and 24, 3 factorial is 6, 24, 30. Yes, if I want to get to 30, then it would be easy. Yeah, it would be better to use these 2 factorial numbers. Yes, so shit, okay, I do not know. Timer is going. That is crazy. Yes, if we were not using factorials and only using powers up to, there would be a unique way to do it. Using the binary representation of n, and the number of terms will be the number of digits equal to 1. In the binary representation, the number of digits which are equal to 1, or bits that are equal to 1 in this binary representation. Let's note this number by ones n. Okay, the number of ones in n. If we fix the factorials we are going to use in the sum, then the rest of the terms are uniquely determined because of the observation above. Note that 1 and 2 will not be considered as factorials in order to avoid repeating terms. Okay, so to solve the problem, it is enough to iterate through all possible possibilities of including and not. Okay, if I only have factorials, all possibilities for the factorials which I can pre-compute, which is something which could be pre-computed, and we are not going to include 2 and 3. 1 and 2 as factorials, then the next biggest is from 6, and I will go, the next one is going to be 4. Now multiply by the 2. 2 into 3, 6, and then 6 into 4, 24. Okay, C out S dot nums dot size, and this thing would not be necessary. This thing is not even happening. 12. There are in total 12 things, and what are the sums which could be used and which could be reached using these 12 things, which it would be 2 power 12, which is not a lot. So we can generate all the permutations beforehand. Well, facts, set, long fact. This will contain all the possible factorials that we could need, except 1 and 2. We are treating them as powers of 2. And in this range, substitute nums with facts, and then void. Wait, okay, I can do this in a singular function called set long nums. This will contain all the possible numbers which are possible to get to. Yes, which are possible to get to. So vector int vector bool, and we are going to implement the same logic which was in competitive programmers handbook for creating permutations, generating permutations. The first one, this logic, and let's do this. Choice size, let's say n equals facts dot size. So we have n choices in total, but we would like to create n as a vector, these facts as a vector, which would be pretty nice. Vector long num, not nums, and this will have facts dot begin and facts dot end. Choices would be n, and initially everything is false. Okay, and then and recursive function. Yes, that was the recursive function. Yes, it was a recursive function. So yeah, I will have to write another recursive function. Void filled nums. This doesn't take anything. This goes through for int I equals 0, I less than fact dot size I plus plus, and this needs access to the choices vector long choice, and what else? Choice dot assign, assign every value will be false initially, and there are going to be n elements, and I also need access to this thing here. So long s, not facts. Instead of facts, let's say s dot insert everything into s, and in here substitute facts with s, and also here reassign to choice. And yes, okay, this thing has now access to choice, and instead of facts, let's make this a vector. Facts dot assign s dot, let's change this thing to facts. Clang D, and this is correct. So that is good. Let's we stop, and we are almost there, I think. Yes, in the CP handbook, this is the second way to permute through things, but like I want to test, do I remember what was the first way? And yes, this would be the easy option, and I want to just see for my sanity check, do I remember how to do this one? Because this one seems a bit more complicated than the other one, and the other one we can just use next permutation, which is pretty nice. We can provide, I think, we can provide a Boolean vector, and it will just keep generating the next permutation, which is pretty nice. But yeah, here for int I. Hmm. And also, shit, there was a number n which is known by everyone, int n initially will be nothing, and I will put n equal to size. Shit, 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 shit. Wait, when am I even using n? Let's say it is f, not n. Start, end, begin. Okay, n is also updated. Okay, and if n, if not n, if n is 0, then I will process the permutation and add it to the nums. Okay, if not n, then long c initially is 0, long, let's just say that, and then I will iterate through choices for int I equals 0, I less than n, I less than uh, uh, yes, int I equals 0, I less than choices, choice dot size and I plus plus. If if choice I is true, then c plus equals that number, facts I, and otherwise not. And at the end, nums dot pushback, no, nums dot insert c. Okay, we have that. And in this else, and yep. Okay, okay, what was the thing? Else, if choice I, if it is true, then continue, else choice I equals true, put it true, and minus 1 and minus minus, and with this call fill nums, and after that n plus plus. I can do this once globally, fill nums, and choice I equals false. Yeah, I think that is good enough. Here we are processing when we have gone through everything. If the current choice is false, if the current choice is true, I cannot choose that number. Shit, I think there is something wrong with this, with the way that I'm handling n minus minus and plus plus. There's also the set which we can use without recursion, but I want to do this this way, even though this is more complicated. If we have two bits inside, if we have two bits, both are 0 initially. The first function call will see that the first one is not is 0, so it will make it 1 and call the function. And the second function call will see that the first one is, and also the value of n here was n equals 2. And at this point, n equals 1. And here it is n equals 0. When this call is made, n equals 0, so 1 1 will be processed. And yes, 1 1 will be processed. Okay, 1 1 will be processed, and then this inner function call will hit back. But the thing is, we didn't make a function call when we had 0 here, which is kind of not good. Yep, which doesn't feel good. Think fill nums. Okay, now with this new thing, initially n equals 2 for both the cases, and the first function makes this first one equal to 0 equal to 1, and the second one remains 0 and becomes equal to 1, and the second, no, even before that, before making it equal to 1, the first in a outer function kept this thing as 0 and made a function call here, and n became equal to 1 when the first function call was made, and the second function went in, and it also, before doing anything else, made a function call for n equals 0. So here 0 0 was processed, this thing was processed. Then that inner function changed this to 1 with n equals 0, and this thing was also processed. And then the inner function rebounded, and the outer function made this thing equal to 1. Ah, shit. Okay, I messed up. I did mess up. I did mess up. I think this is right. Okay. I don't know. Shit. This finding the permutations is kind of crazy. Second laptop suggest Python. I don't know much about laptops. Problem link. Yes, this is the one. You can solve this. And for programming, you do not actually need a very good laptop. Any laptop is good enough for programming because it does not take a lot of resources to program, and you can buy any laptop which fits your budget and it would be good enough. Yep. Any laptop would be good enough for programming. Yo, connections. Okay, I think the permutation part is right now. fill nums, but before fill nums, I will call fill facts. For int I or auto reference x and nums cout x with a little space, and I hope there is at least not an error, or maybe there was. Wait, uh, in this function s dot size f. Wait, what is the error? Int f 35 no, was not declared. Yes, it makes sense. Long f equals 2 initially. And what do we have? What do we have? We have an empty thing. Nums dot insert. Nothing is getting inserted into nums. Which is kind of bad. Okay, because I didn't call the fill facts function. Fill nums. Okay, still it is empty. Fill facts is calling fill nums. And I do put n equal to size of s, which is hopefully non-zero. I think it is s dot size. It is 12. So n is also 12. Makes sense. You're welcome. Okay. Let's go with the simpler implementation. Sure. Okay. Let's go with the simpler implementation, and which would be something like int n. Okay, what do I need? I need facts. I do not actually need choices. I do need nums, but vector would be fine. A vector would be fine for nums. And here, int n. I don't even need int n. Now, vector of Boolean values, choices, size n. What is n? N is facts dot size, and everything is false initial. Think do something while next permutation. How do you call the next permutation function? Next permutation function C++. Yes. Bidirectional iterator first and last. Okay. Function returns true if there is a next permutation. Okay. While next permutation for choices dot begin and choices dot end. While this thing is true, let's have a long C initially 0 for int I equals 0, I less than, let's say int n equals facts dot size, and here n, the size of this thing is going to be n, and I less than n I plus plus if choices I, if this thing is true, then add this to C plus equals facts I, and after getting the value for this permutation, nums dot push back C. Okay, that is cool. And we will also see how this thing looks like. C out nums. Oh yeah, there is a mistake for choice. Okay. Wait, what is choice? Wait. Fill facts and then just this thing fill nums, which will be called 0, nothing, empty, shit. CPHP, Competitive Programmer's Handbook, what was the way? Shit. I cannot even remember a little thing. Okay. While next permutation, where this thing is something. Permutation dot begin, permutation dot end. This is the thing that I'm doing here. Next permutation for choices. Okay, since everything is 0. Yes, yes, yes. Okay. Shit, 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 shit. This is not even needed here. Int long long choice equals 0 long long. Okay, and y choice lower than the number of elements in n in facts is 12, so there are going to be 12 bits, while this thing is lower than 1 long long left shifted by n plus 1. If n is equal to 2, then I will go 0 0 1 1 0 and 1 1 1 1 is 3, which is smaller than 4. And if n is 2, left shift 1 by 1 is 2, left shift 1 by n. So not plus 1, but just 1, because left shift 1 by 2 gives us 4, which is the higher limit. So this is cool. Okay. For int I equals 0, I less than e less than n I plus plus if choices take and of choices with 1 long long left shifted by I. If that thing is 1, then long long C equals 0. C equals 0 and C plus equals this facts I. And then nums dot push back this number C. And then choice plus plus. Okay. Refactorization. Choice and choices. Okay, this thing is still 0 somehow. Even though I'm doing nums dot pushback here. And N is, wait, what? N, why is N equal to 0? Is no one filling facts? Long. Shit, my bad. Reassign facts. Okay, cool. Wait, that is not very cool. Shit, that is not very good. Wait, that might actually be good, by the way. Let's see. G++, C facts, dot slash out, and these are same. 939282682093928268280. 93928268280. These numbers are not changing, which is bad, and the other number is always 0. Take bitwise and of 1. Yeah, now it is better. Clara, clear. G++, yes, dot slash out, and yes, okay, this is good. This is good. This is good. This is actually good. Now we have all the sums of all the possible factorials that we could have or anyone could ever hope to have. And let's also see how many there are. See out nums dot size, not just this, end line. There are just 4096, which is exactly 2 power 12. It is exactly 2 power 12. So everything is fine till this point. Do you give only, yes, only code forces contests, no other ones? Can you say how to set up the problem parser for Vim assign that you use like the problem test case and file creator? Okay, for this, uh, when you go to any problem, you also need this extension, competitive companion. I think you might already have this. And then you like, if you are using lazy or whatever you are using, I have a separate file for plugins, a separate directory for plugins, and in this directory here I have the plugin, assistant plugin, and yes, so this is how you uh, use or like add a plugin using lazy. You return a struct from Lua where the first entry is going to be the name, the GitHub name for the plugin, and these are some custom options which I have set. When I want to bring up that window, let's say nc factorial.cpp. When I want to bring up this window, I press cpp, leader cpp, which you can change from here. And there is also this command, and there is also, this is the description. And then here I am telling for cpp, for C++, template is nil. I'm not adding any custom template. And for compiling, these are the commands. I am using GCC 15 for compilation. And also I am including this thing right here, which is include this is a custom file which I have added in inclusion because there are some things that I need, and the standard is also can also be given from here, and just all the arguments which you would know. Did you upload your nvim config or GitHub? Yes, it is on GitHub nvim rc, this one. Yeah, here you go. Everything is there, and set. Now I see why I have to include the std limits thing. In bits std, and here include c, bring this limits, and let's see start clang d. Yeah, okay, that is cool. Emacs attach pcp, and yes, going back to the question, size is also cool. And now for int I equals 0, I less than nums dot size I plus 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 plus. And we have to see with which number do we get the least amount of ones. So how do we calculate the number of ones? Shit, this is just some binary thing. We have to calculate. What we essentially have to calculate is, shit, I have two numbers. Let's say 11101 and another number. This is x, this is y. They both look like x and look like y. This one is y and this one is 0 0 1 0 1, and I want to see how many ones they have in common, just the number of ones. And if there is a extra one, then I would like to remove that one. Yes, I would like to remove that one, or I would just not like this, something not like something like this. And so first I can take or of these two things, x or y, and if this thing is bigger than x, then I just discard this y. This y is bad because this y has some ones which are not in this x, so that is bad. Now after this, if this thing is true, I know that this y has only ones in the places where there are ones in x, and now I want to see how many ones there are in this y. I think I just have to go through this number, which is around like more than 32 bits in a loop of 32, which is fine because in total we have 4096 numbers, and a lot of them will be discarded because of this thing. And let's say none of them is discarded with this thing, then still we would only have to go for about, let's say, 40 bits in each number. Yep, or since we are using long, let's say we are only using 64, we are going through all the 64 bits, we do not have to optimize for that. This is fine. This is fine time complexity. Yeah, that's if long x in nums. Now, if n or x, this thing is greater than n, this has to be like exactly equal to n. Only then do we entertain the possibility that this could be it. And k or answer equals int max or 0, because we are looking for the maximum number of ones. Now, if this thing is true, then this x only has ones in the places where this n has ones. Now we want to find how many ones there are in this x, for which we can write a simple function, external function. And I think there might actually be a function for this, but fine. Int once, this takes in a long number x, and answer is 0. For int I equals 0, uh, uh, I one long left shifted, or I smaller than 64, I plus plus 64, 63. Okay, just to be safe, so that we are not going till the last bit. Okay, the last sign bit of this thing. Then, okay, if x and one long left shifted by I, if this is 1, then answer plus plus and return answer. Answer equals maximum of current value of answer, or ones in x. And here we also have to see in tar the total number of ones in target, which is n, ones in n, and the maximum number of ones that we were able to get. But shit, how many fact shit. I need two numbers to describe that thing. Shit, how many factorial numbers were involved to get to that sum? Shit, yes. How many factorial numbers were required to get to that sum? Shit. I have no record of that thing. So I guess pre-computing this thing is not really good. I can compute this every time I am going through the thing, which is nice. Fill facts, I can fill facts beforehand, but this thing may be. Find the number of factorials which are being used. Yes, find the number of factorials which are being used. Okay. n equals fact dot size c out n. No. Nums, I don't have to push back c. C is the current number, and I can do choice plus plus, which is fine. C is the current number, and I can find the number of ones in C, and also change this n. S Z, find n, change by size. Okay, and shit, why is this not working out? Okay, calm down, and I'll be able to do it. Yes, I will do it. Don't worry, we'll get this right. Okay, now if this current factorial has higher number of ones, C is the current number. So if I take XOR of C with n, and this number is exactly equal to n, so this current C is something that I can use. Yes, this current C is something I can use. Okay, and why would I choose this C compared to any other C? Answer will have the number of factorial numbers which have been added to get to this number. And int O is number of ones in choice, which represents how many, yes, number of ones in choice, which represents how many factorial were used for this. Okay, and if there are two things, if I want to find the combination of factorials which eliminate maximum number of ones, and also keep in count how many factorials how many factorials were used to get to that sum, which is reducing the number of ones. Okay, if ones in this factorial, which is C, if ones in this C is higher than what is in the answer, then I should go with this, right? Yep, I think I should, or I think here I should go from top to bottom. Choice, therefore, should be decreasing by one, and this thing, nah, this is fine. Number of ones in C, if this is greater than answer, then and done. The number of ones that have been done is 0 and not this. If this thing is uh, done, if the number of ones in this current one is greater than done, and done equals if ones in n in C is greater than the number of ones which already have been done, then update done to be equal to the number of ones, and we are calling the same function twice, which is kind of bad. And we don't actually need this one. O equals ones in C O CEO. Okay. Done equals O, and also in K equals int K. K equals the number of factorials that we have used, which is, let's say, initially 0. K equals number of ones in choice. That is the number of factorials we used for eliminating this many ones, which is done. Now, K plus equals, and to K, the number of ones that we needed, which is ones in n, minus the number of ones which have been done. See out K, and this is going to give me a big error. Okay, wrong answer. That is much better than an error. Okay. Why is it always 1 or 2 greater than the correct answer? Ah, the number of ones in, and that was bad. Shit. Because done is the number of ones that have been done. Okay, shit. Done equal to O. Ah, how is it even negative? Okay, okay, that is much better. And this thing is the only one that is wrong. Mm, hmm. I am giving out a higher answer than what is the actual correct answer. How many did we got done? And what was the k value initially, which is the number of factors that we used? Key, we used two things and we got done with 3 ones in this using two factors. We got done with 3 ones. That is okay. And in total, how many ones there were? Ones in n. In total, there were 4 ones, and we got rid of 3 of them. Then the answer should have been 4. So why is it this? Okay, done is the first thing. In total, there were 4. And using 3 factors. Okay. So see out minimum of k, comma, ones in n. Okay, that is giving the right answer. That is giving the right answer. And let's submit this and see if this thing is going to work. It's going to be cool. Let's see. But before submitting this, first of all, I will go to the washroom, and second of all, I will delete the whole code and we will write the code from scratch again. It is going to be cool. Okay. And I will be right back. Let me go to the washroom. I'm back and let's get to it. We will write the whole code from scratch, which is going to be fun. Okay, this is the thing. And what we have is just a long number, long number n. We take that in, but we need some pre-computation. We need a vector long, which has factorials, or we can say, yeah, vector of long fact, which will contain all the factorials which we could use. And we will also have a function which returns void and which is going to fill this factorial vector. And we will say long n equals shit, we are not going to use this. Shit, we are not literally not going to use this. We are going to go internal. There were a lot of things. And we will need a function which takes in a long number n or x, and this finds the number of ones in this function. For int I equals 0, I less than 62 or 3 is fine, I plus plus, if x and with one long left shifted by I times, if it is 1 then answer plus plus, and at the end return answer. This is going to help us in finding the total number of ones in a given number. Now we want to find all the factorials which are possible to get. Let's say long. Okay, yes, there are two things. First, there are all the factorials which we can use, and then second, there are all the combination of factorials which we could use, which are two things. So we will need the long vector which stores all the factorials and a function which fills that fact thing. And the smallest factorial which we are considering is going to be long n equals initially 2, which we will not consider, but for n I equals 3, the third factorial, if I into someone is calling I into n is still smaller. Wait, I can make it this long. It is fine as it is. If I into n is smaller, then our range, yes, we also need a range constant. Range is 1e equal plus 1. If this thing is smaller than range, then go ahead and also create a set of long long, it will be called S. And let me actually see who is calling. It would be a nice information to have. Wait a minute. Yep, let me just see. Okay, it is fine. It is fine. Hello. Yep, it is fine. And yeah, yep, it is fine. And yes, we will have a long set. And if the current number is good, we can insert that number into the set. And before inserting, we can say n multiplied by equal to I. Multiply n by I and s dot insert n. Okay, and we will update the fact vector assign s dot begin and s dot end. Okay, fact is now updated. We can get back to our function here. Long, long, nothing. Long choices or choice initially is going to be equal to 0, long, and like there is the permutation way of iterating through subsets where each element is represented by one bit, and if that bit is 1, then you do include that element into your permutation, and if the bit is 0, you do not include that element into your permutation, and in total you will have the same number of bits as the size of your set, which let's say is sz. And yes, int sz, the size of our set is fact dot size. And let's also call the fill fact function right here, and we will go, or we don't really need this. We can say this thing here for long choice equals initially 0 long, and while choice is smaller than 1 long left shifted by the size and choice plus plus. So with this choice, what is going to be the current number, which is represented by C, and we will go internally through this current choice, and I equals 0, I less than what? I less than size and I plus plus. Now, if this current bit, this ith bit in choice is 1, how do we check that? We take choice and with 1 long left shifted by I amount. If this thing is true, then C plus equals this ith number, in fact, which is fact I. Okay, in fact I, and we take forward from there. I just found your stream. What are you solving? I am doing Striver's sheet and have done almost 60% of it. That is amazing shit. I think I have only done 6%. 60 is a lot of it. When and how should I start CP? And you mean competitive programming by CP? And you can just start. Just don't worry, you can just start doing CP. And if you need to find the questions, you can go to this sheet and you can go to 800 rated questions, start solving them, and slowly move forward, and that is cool. You can do that. This is the sheet. Here you go. And I have spent almost 2 hours on this question. That is amazing. Yep, so I have the current number. Now, if this current number is choosable, which means if I take its OR with n, that value exactly has to be equal to n. If this number is choosable, and I also need some other numbers, int k equals 0, the number of factorials which I have chosen, and int done, the number of ones which are done is 0. Okay, if this current number is choosable, now I need to see how many ones are going to be required for this. How many ones is this eliminating? The number of ones it is eliminating is the number of ones in C. And if C, the number of ones, if O, the number of ones which this current C number is eliminating is if it is greater than done, then I will like to update done and also K. K is going to be equal to the number of factorials which were involved in this, which is going to be the number of ones in choice. And that is it. And then outside K plus equals the remaining number of ones, which is going to be the number of ones in N, that is the total number of ones, and minus done, that is the number of ones which were left. And now see out minimum of either K when we are using factorials and numbers, or just using powers of 2. Think this could mess up because, okay, let's say if this and else if O equals done, that is the number of ones that I'm eliminating is equal to the number of ones that have already been done, when K is going to be minimum of either the current value for K or the ones that I need to make this choice. That is that is cool. Okay, that is also wrong because done is very big. I think done is not equal to C, done is equal to O. It is still wrong. Uh, this thing, fill facts, I did call the function fill fact, and this one function is also cool. If the number of ones that I'm eliminating is greater than the number of ones that I have eliminated, then update K, the number of ones in the choice, which is the number of factors I am using for this. And yes, and done equals O, the number of ones that are done with this current choice. K equals minimum ones in K or choice. Ones in N minus the number of ones that were done. Okay, yes, this is because of this. Okay, that is working. That is working. That is working. Let's see. You're welcome. Which neoem distribution are you using? Uh, LDTS. What is LDTS? Shit, what is LDTS? LDTS in chat. Uh, IDTS. I don't think so. Huh? Is that it? And what do you mean by distribution? There is just that one single source of truth distribution, right? This one, neovim from GitHub. This is the one, the official one. And let's see and submit this one. Not IDTS. I don't think so. Lysium. Lysium is for plugins for automating the plugin process. for plugins, not it is not a distribution of new Vim, I would say, because all the plugins I have chosen manually. Lazy is just downloading the plugins, not telling me what plugins I should use. Okay. Moment of truth. Okay. Uh, 2 hours. It took 2 hours. Okay. Oh, why is it not even running? Okay, why it? Ah, ah, shit. Okay, I messed up. I messed up. Output is wrong. Output is wrong. Expected 12, found 40 for the second number. Just the second number. For this number. Expected 12, but found 40. 40 is very bad. Plus recompile. I have just one number, which is this behemoth. Answer is answer is not 20. Answer is not 20. Answer is not 20. Like yes, it is not. Interesting. Can you share the config or the dot files you wrote? Yes, you can go to this website, which is GitHub slash my name and slash nvimrc. Let me resend it. Where is copy? Go to channel. You can go to here. All of my config is there on this website, and I think I can skip this question for now. After 2 hours, I think I can skip this question, and we will come back to this one later. For now, this one. Baby eHub, and yes, it's been 2 hours. Let's go with this one. Stopwatch, not even a single question done today. And it's been 2 hours, which is crazy. Okay, let's do this one. Baby Ehub, is known for his love for a certain operation. He has an array A of length n, and he decided to keep doing the following operation on the array. He picks two adjacent elements. He then removes them and places a single integer in their place. Why do I feel like I have done something with this? No. Their bitwise XOR. Note that the length of the array decreases by 1. Yes. Now he asks you if he can make all the elements in the array equal. Since babies like to make your life harder, he requires that you leave at least two elements remaining. Wait, is this it? I just need to figure out if I can find prefix XOR and iterate. Okay, if I think what this question is asking me to do, then this is very easy. If I think I'm right, and I think I'm right, int n, it for each test case I have n and then the numbers. Okay, zero. Zero is going to work. Yeah, zero is also going to work. Fine. And what is the maximum value for a? A can be 10 power 2 power integer 2 power 30 is integer. A size n, for int reference x in A, c in x, and vector int ref size n plus 1, and for int I can directly create a prefix, which is great. Int I equals 0, I less than n, I plus plus, ref I plus 1 equals ref I XOR AI. Yes, and then for int I equals 0, I less than n, I plus plus, and bool p equals false, and cout p if possible, then yes, otherwise no. Then new line, no flushing, and here for each, and AI represents I am using all the numbers from 0th till I, and I is included on the left side. So what is the XOR of all the numbers on the left? It is going to be all the numbers on the left, pref I plus 1. For all the numbers on the left, the XOR is going to be pref I plus 1. If this thing equals, what is the XOR of all the numbers on the right? It is going to be XOR of all the numbers ever, which is pref n plus 1. Take its XOR with all the numbers on the left, which is pref I plus 1. If this thing is true, then P equals true and B. Let's add some brackets so that we don't mess anything up. I think that is right, or maybe not. Shit. Okay. Size is n plus 1 a I. Take everything into a. Ref prefix I plus 1 is prefix I, XOR prefix a, AI, odd. Okay. This is also not going out of range. This is also not going out of range, and this is also not going out of range. So what is the problem? LSB start line D. Is there some problem with that? What is the problem? N is at maximum 2. AI is at maximum is smaller than 2 power 30. That is, it can be represented using 30 bits. For int I is always less than n. P equals false. I cannot see the mistake. Pref I, prefix I, pref I plus 1. Here I'm taking in everything correctly. Here also everything is fine. And here initially everything is 0, which we can be very explicit about by saying that everything should be 0. Okay, I do not see just what the mistake is. Vaga something. It is compiling here. It too many arguments. Okay, my bad. 2 There are only two test cases. First one is 3, 0, 2, 2. Okay, failed. Why? Abort. Why abort? Size of A is n c into x. Pref. I am somewhere indexing something that is outside the range, but good, good. This is correct. This is like I'm very pretty sure about this that this thing is correct. Okay, okay, Sh shit, no, I don't think. Okay, this is wrong somehow because he is always choosing elements that are adjacent to each other. This should be working. I have, let's say, just one test case which has two numbers, 3 and 3. Yes, and I am taking XOR of all the numbers on the left, which is equal to this thing, and XOR or of all the numbers on the right, which is absolutely equal to this thing. Mhm. If these two things are true, then P equals true and break. Okay, I would actually like to see the test case in which I messed up. In the fifth token, expected yes, but found no. In the fifth one, 1, 2, 3, 4, 5. This one. They are same. They are same. Only one test case which has three numbers, which are these. No, yes, no does make sense. Wait, no, no does not make sense. No, no, no does make sense because we need at least two numbers at the end. Therefore, we will have to take XOR once, at least once, and when we take XOR of the same number with itself, we get 0. So we will get 0 on this side, and we have this big number on the other side. How is it? Yes. In the first example, he can remove the first two elements. Uh, he can remove the first two elements and replace this XOR with 2. Yes. And replace them with 0 XOR 2, which is 1. Yeah, cool. Okay. And also, I should say lower than n minus 1 because we always need to divide this into two things, and we should not go till n minus 1 because we would be thinking of the whole array as one thing on one side, but we also need something on the other side. G++, compile again. Only one test case which has three numbers. Which are these three? Still no. Why would it be yes ever? Does not make sense. On the fifth token, the answer is yes, yes, yes. I said no, yes, no, yes, then no, and yes, 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 and no, and yes, no, this thing, which is no, yes, no, yes, and then no. This is the problem, the fifth one, which is this is no, this is yes, this is no, this is yes, and this is supposed to be yes, but I'm saying no. But how would this be possible? Because these three are exactly the same numbers. 622 815 211 96 9628 15211 96281 5211. Okay, when you take XOR of a number with itself, you will get 0. So, maybe the problem statement. Baby Eva, he picks two adjacent elements and he removes them and places a single integer in their place. In their place, there's XOR. XOR. Note that the length of the array has decreased by 2. Now he asks you if he can make all the elements of the array equal. Since babies like to make your life easier, he requires that you leave at least 2 elements remaining. Okay, so I can have 3 elements or 4 elements or 5 elements or any number of elements. Shit, that does make a lot of sense, I would say. So I can keep taking XOR and at the end I might see a 0 or a XOR that was earlier present. Okay, this is actually okay. This is a bit different. We don't need the prefix or anything. Let's we stop because I thought we had to make two. We had to keep exactly 2 elements, but it is at least 2 elements. So I messed up. My bad. So what we will do is after taking in the array, we will create a set. Yes, we will create a set which will have all the XORs which we are ever going to have. Int z, z is fine. And for int I equals 0, I less than n, I plus plus, int z, zr equals 0, and zr XOR with the current AI, and set x dot insert this XOR. Now, bool p equals true if either zr, if zr is 0, or either zr is 0 or we have x dot the XOR that we have already seen it at some point except the last. If I lower than n minus 1. If we have already seen it in the set, yep, if we have already seen it in the set at some point, dot count zr, yep, correct answer. And I think this is also going to work for those cases 1 and 3, 9 6 2 8 1 5 2 2 1 1 and 962815211 and 962815211. Yes, this is working. That is cool. Submit, 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 submit. And hopefully this one. Okay, shit. That question mark means there is some mistake, which is a mistake. Shit. That means there is some like overflow or something. Maybe this set, but the maximum size of this set is going to be n, and that is fine. What is the problem? In the ninth element, you found no, but expected yes. In the ninth, okay, shit. There are only 15 test cases, and all of them have about 2000 numbers. And I said no, but I should have said yes, and not just that. Answer is no. This is my output. I am saying yes for a lot of things which shouldn't be yes. Expected no, but found yes. That is the problem. Why is it yes? Either ZR is 0. That would mean the number of groups that I'm creating is even. That would mean uh, the number of groups that I'm creating is even. But if the number of groups that I am creating is odd, I'm thinking of this like this. If I do divide all of these numbers into groups of XOR, then I will have numbers like x1, x1, x1. Since this is the final representation of the end array, and in the ending, the array in which all the numbers, all the elements are equal, that array, this array, which has at least two elements, at least two elements, at least two elements. How do I check? Ah, that might be the thing. That might be the thing. I might be choosing x1. No, I'm only inserting elements before taking XOR with the last element so that I always have the last element as a separate element. And if the final array has even number of elements, then all of their XORs are going to become, if I take XOR of these numbers, it is going to result in 0, because when I take XOR of these two numbers which are same, I will get a 0, and when I take XOR of these two numbers, I will get a 0, and every number can be paired up with another number in total. Therefore, I will get 0. But if they are odd in number, then I will get one instance of this number. And that is the two things, those are the two things for which I'm checking here. If the current ZR XOR is 0, then, which is this case, and if this XOR, which is here, I have seen it before, which would mean I had a XOR and I came back to that XOR, and all the elements in the middle gave a XOR of 0. All the elements in the middle gave a XOR of 0. Shit, okay, this is harder than I thought. It would have been easier if I had to just have exactly 2 elements at the end. But no, this is a bit harder than that. X dot count ZR. This part is bulletproof. I have no doubt with this. If the final XOR is 0, that means I must have gone to some place and found some number, and then I found another number on the right side of that place, and when I take XOR of those two numbers, I get 0. Boom. So not ZR is correct. But this part, I'm not very rigorous about this part. X dot count ZR. Count, have I seen ZR ever in X? If I have seen this before, that would mean something like I had this is my vector, and at some point I got a XOR, let's call it ZR, and I took a bunch let's call the XOR of these two numbers, of all of these right numbers, Z3, Z2, this is Z1, this is Z2, and what we have is Z1 XOR Z2 equals Z1. So this must be 0. Okay, this makes a lot of sense. This makes a lot of sense. Having XOR at this place equal to 0 does not necessarily mean that the even point where I divide this XOR into two places also equals x1. Okay, that was a wrong expectation I had out of this thing. That makes sense. But for even case, this one is bulletproof. This one is not too much. I thought of Charlie Kirk there, but okay. Yo, hello. This is Vim. Bro, have you read the CP handbook fully? No, not fully. Not fully. There are quite a bit of it left, but I've read a few graph chapters and the starting chapters till dynamic programming. Okay, Zor. And your binary things is bad, right? Bit manipulation things is not pretty cool, not really good as you'd like it to be. I think you can do some assembly questions. Maybe that might help. I don't know. Maybe that might be helpful. I cannot be sure. Okay, so we have to consider for the case when I am dividing this thing into even number of groups, into odd number of groups. When I am dividing this thing into odd number of groups, I have a group here and I have one group whose XOR equals 0, mhm, whose XOR equals 0. Yes, whose XOR equals 0, and I can actually do this manually. It would be easy to find out this point, and then I can apply my seam prefix algorithm to find the point where the XOR of the left side equals the XOR of the right side, XOR left, XOR right, and what is that XOR? And if this XOR equals this XOR from this odd one out sequence, then answer is right. Otherwise, answer is no, no. And if we are going to do that, then we would need something that is not a set, something that is a map. And we'll do x XOR equals I. We are getting this XOR at this index I. And now, if on this, if not, if ZR, if we have a XOR, bool P equals false. That is going to be the default behavior. P else P equals true and C out depending on P question mark. P yes, then yes, otherwise no, and a new line also. But if the last XOR was not equal to 0, right, then my phone might die out of low battery. Wait, what? No, shit. Okay. Hmm. Uh, Here. Now, if XOR is non-zero, and if I have seen this before, which is if x dot count ZR, if I have seen this before, only then do we create the prefix and we solve this thing. Yeah, we're gonna try assembly problems. I reached complete search right now in CB book. Complete search is nice. It has shit. That is why you were recommending. Oh shit! It was, I guess, Prism who was recommending the next permutation approach. Yeah, that is nice. Complete search is a nice chapter. Backtracking, the queen problem is nice. Pruning and meet in middle, these two things are nice. And there are two ways for generating permutation, and I guess two ways for generating subsets. What are the two ways? This recursive one, and there was this. Yeah, this is the one that I like. This one is pretty nice. Yeah. Anyways, for assembly, you can start assembly from Larry, not Ellison. Assembly. Larry. Larry is the name of the author. Yes, this book by Larry Piet. This is the one that I used for assembly, ARM assembly specifically. This is not for x86, but starting with ARM is okay, and then you can move on to x86. But yeah, you can start from this. This is the place where all of my assembly knowledge comes from. This is the book. You can download this or do anything with it. Now, when we are here in I equals x XR, this is going to have the last index where x was present, which had XR. Yes, this is going to represent the last index which had XR. So I have to go from I plus 1 till n minus 1 and see if, yes, and see if the last number, if that thing can either it is exactly equal to, no. Okay, yes, it is going to be even because XOR for that thing was equal to 0. If uh, we will create a prefix vector in depth size n plus 1, not n plus 2, n plus 10, for int I equals 0, I less than n, I plus plus, ref I plus 1 equals ref I XOR AI. We have the prefix, and yes, what we need to see is what is the point where the XOR on the left side is equal to the XOR on the right side. Left limit is this and a right limit is n, where left is included and neither left nor right are included. Left is included now and right is also included. Let's say right is not included, and for int I equals L is included, I less than right is not included, I plus plus. Now what is the XOR of the numbers on the right? The XOR for the numbers on the left, the XOR for the numbers on the left is, and also let's not say anything. If XOR for the numbers on the left is going to be pref I plus 1. No. Pref I plus 1. Okay, this is bad. We will start this thing from left because that is all that we need. Okay, cool. This is cool. Then here I can very easily do this XOR of all the numbers till I, where I is included. Is this thing equal to pref n XOR of all the numbers ever present and pref I plus 1 XOR of all the numbers on the left. If this is equal and whatever this XOR is and this ref I plus 1, this XOR equals the XOR that we got at the end. Only then do we say P equals true. And this is giving the right answer here, G++. Let's see for 13962815211 962815211. Should I mess up? 1 3. Yes. Yes. This might actually work now. Like for real, for real. Okay. Uh-huh. Shit. Shit. Test 16. How? How? Shit. Test 16. 16 is crazy. 16 is actually pretty crazy. Answer is yes, but I said no. Get out of here. Because if I take XOR of these two, I get 0. Is output. If I take XOR of these two, I get a 3. Uh-huh. Okay, so this must have been by a hacker after the contest. Okay, and I had 3 initially, and then we had 0, and then we had 3. Uh-huh. And then 0. Hmm. We can fix that. We can fix that. We can fix that. If I is lower than n, and x dot count zr is not it has not been seen ever before. G plus plus 1, 3, 4, 4 numbers. That's this out. 1, 4 numbers are going to be there. They are 3, 3, 3, 0. Yes. And also, does it still work for these? 1, 3. This is one number. Uh-huh. I think now it is correct. Now it is. What if the number is reversed? Numbers are reversed. Okay. Dot slash out 1, 4 numbers 0, 3, 3, 3. Okay, cool. Alright. This might work. Hopefully. This is hacked for sure. Yes, either after the contest or during the test load. Yep. Yeah, yo, let's go. 40 minutes. Okay, 40 minutes is okay. Nah, 40 minutes is not pretty cool. I would have been able to do this faster. Yes, if. So what were the things that I messed up? The things was, first of all, I didn't read that I need to have at least 2 elements, not exactly 2 elements. And after knowing that, I should have thought that this whole vector can be divided into multiple groups. And if there are even number of groups, all having XOR equal to each other, then if this is my final array, then if I take XOR of the whole thing, I will get 0. But the final array might look like this, where I have a number, even odd number of times, and then one thing would give me a XOR of 1 and the other would give me 0. I just need to find the index of this thing and see that the XOR of this whole thing is 0. Then what is the XOR? Like if XOR of this whole subsection is 0, that would mean at some point I had some number. I can divide this subarray, since this subarray has a XOR of 0. It means I can divide this subarray into 2 parts which have the same XOR, and I just need to find this section to find this XOR, and if this XOR equals to the XOR that I have taken away, then cool. Okay, but I think I would not have been able to do this during a contest because I needed guidance of the problem statements which I messed up. Okay, what were exactly the things? Where are the submissions? Yes. First, okay, first mistake was obvious. It would have been avoided if I had read the problem statement correctly. The second mistake, the second mistake is not too obvious. The second mistake was not too obvious. Yes, but I guess I would have been able to figure this part out, that I need to check the XOR that I'm getting from this other array. Is it equal to the XOR that I have left? But no, I think that is too much expectation. I would not have been able to figure this out. So I would not have been able to do this during a contest because I cannot see the things where I'm getting the wrong answer. And this one, if I had gotten to a code like this, then getting this error, I would have fixed it because I would have known instantly where the mistake is without even looking at the test case on which I got a wrong answer. Let's write this again. Int n, take n and vector int a size n, and for int reference x in a, c in x. And now, yes, now we need some pre-computation. Map int mp or xr to find all the XORs that we are getting throughout, and also the second value in the map. The value in the map is going to be the index and the key is going to be the XOR. And also int z, which is initially 0, which is XOR of all the elements till the ith element. For int I equals 0, I less than n, I plus plus x XOR with ai. And if I is smaller than n minus 1, and I have not seen this XOR before, which would mean if not xr dot count count the occurrence of x. If I have not seen x ever before, then xr, the key is the current XOR equals I, the index. Now, bool p is false. We are just supposing that it is false. And x if x is not 0, then something, but if x is 0, then it is possible. P equals true, and depending on P, we do yes or we do no. A new line here. If I've seen this XOR before, let's say, if x dot count x, if I have seen x before, only then we will go through the trouble of doing all the next things that we are doing. And left limit is going to be xr x plus 1. xr x, this part is the index starting from 0 till this xr x is the index where we got this zr and this XOR z. But now our subarray starts from the element that is to the right of this element, and that is going to be our limit. Left limit is going to be inclusive and right limit is not going to be inclusive. And we will create a prefix vector int pref size n plus 1, and for int I starting from the left limit, because L is inclusive, I less than 0, I plus plus less than n, not 0. What is I less than 0 means pref I plus 1 equal pref I XOR with the current element. Now after this we need to find what the place is, what the index is from which I can divide this subarray starting from L to R into two subsections which have the same XOR, so that when I take XOR of these two subsections I get 0. So for int I equals L, starting from L, I less than N, R, do I do R minus 1 or R? R is also fine. R minus 1 is also fine. This is fine. R I plus plus. Now, if at any point the XOR of all the numbers on the left is pref I plus 1, that is the XOR of all the numbers on the right, on the left, and XOR of all the numbers on the right is XOR of all the numbers ever. XOR, take their XOR with XOR of all the numbers on the left. And if this XOR I plus 1, if this XOR equals the one that we are looking for, which is X, then this thing is very much possible. P equals true, and we can break free. And you might have heard the song I Want to Be Break Free. Okay, this is cool. I hope this works. Okay, might have been embarrassing a bit. Let's see if this is working. Submit. Okay, hopefully this works. Hopefully. Shit, maybe I messed up. Or maybe didn't. This one took longer than the earlier one. That is fine. Refresh. So that is done. We have only done one question today. There's also a contest today, and that is fine. That is fine though. Let's okay. Now the editorial for this one, and I guess I won't be doing any more questions other than this. With yeah, just a single question for the day. That is bad. So let's try to understand what the final array looks like in terms of the initial array. The best way to see this is to look at the process backwards. Okay, basically start with the final array and keep replacing an element with two elements that XORed down to it. Okay, until you get the initial array. You will see that the first element turns to be a prefix. The second element turns to be a subarray that follows this prefix, and so on. Hence the whole process of moving, my bad. Hence the whole process of moving from initial to the final array is like we divide the array into three pieces and then replace each piece with its XOR, and we want these XORs to be equal. A nice observation is we need at most three pieces. At most, yes. We can do it in two pieces, or we can do it with three pieces if there are like odd number of things in the final array. And if there are even number of things, then we can make them equal to 2. Yeah, that is because if you have 4 or more pieces, we can take 3 pieces and merge them into one. Yes, yes. its XOR will be the same, but the total piece count will decrease by 2. Now, if checking if you can divide it into 2 or 3 pieces is a simple task that can be done by brute force. You can iterate over the positions. You will shit. Since we need to split this into at least like 3 pieces, and so we can go n square. N square is fine. N square is fine. N square is fine. Yeah, n square here is fine. But I think not that I think. I know for a fact my solution can take n values up to 10 power 6. Yep, my solution can take n values till 10 power 6. So this is better in like the range, but the thing is I could have seen looked at this thing and could have arrived at this solution also. Additional idea: for 2 pieces you don't even need brute force. It is sufficient to check XOR for the whole array is 0. Hint, see the right, the brute force. uh, that is okay. Yeah, okay, okay, that is okay. Can you give me a guide? I'm in 4th year and starting my DSC journey. I know I am cooked, yes, but any advice how to start programming? I'm right now doing need code questions. Okay, so the best time to start programming was when you were 9 years old, and the second best time to start programming is right now. And I guess you have the second best time to start programming. And if you want to get into competitive programming, there are these resources which you can use. Competitive Programmers Handbook. And since you are already in your 4th year, you would be expected within a year to get to get a job. I think you like expected to get a job. And if that is the case, then you should do, yes, yes, you would be expected. So if that is the case, then I think you should focus. Okay, DSA is necessary. DSA is going to help you everywhere, no matter what field of programming you go into. So you can keep doing DSA side by side, but since you would be required or expected to have a job in a year, then I would say by side you work on something which can help you get a job faster, like web development or some development thing which can help you in getting a job, and also DSA side by side. Yeah, okay, AIML is cool. AIML is cool. You can do AIML, you can get internships or done WebD. So, okay, so if your job security is fine, but I still, yes, DSA is necessary. So, okay, if your job security is fine, like you do not, you know that you will be getting a job and that is not a big deal, then just you can start doing DSA carefree. And I would suggest you do competitive programming, because in competitive programming, when we give contests, our rating goes up and down. And when it goes down, like right here, it went down and down, you feel very bad, and that makes you stronger for not just competitive programming, but for life itself. And that is something that I recommend highly. So you can start doing competitive programming. And if you want resources for competitive programming, in the beginning, you only need 2 things: questions and theory. For questions, for theory, you can go to this book, Competitive Programmers Handbook. And for theory, you can go to this sheet, CP31. Shit, I'm messing this up completely. For questions, you can go to CP31. And for theory, you can go to this book, Competitive Programmers Handbook. You can just look it up, Competitive Programmers Handbook. You will find a PDF. And for this is just fine. TLE eliminators, this is what you can do. If it is online, free. CP and book. There you go. This is like published by the author himself online for free. And what is this font? Shit. Uh, yeah, it is taking time, but yes, this is the PDF, the official website to get the PDF. And that is cool. That is what you can do. And for the day, this this would be the end for today's stream, I'm afraid, because yeah, it has been long. 3 hours and 5 minutes. That is fine, not pretty long, but fine. And yep, this is the end for today's stream, and thank you for being here. Bye.